Hello Year 11, you wonderful lot. Just wanted to give you the opportunity to take part in a bit of a walking mock. So I would really recommend having a copy of the paper printed out, or maybe having it open on your phone next to you whilst you're looking at this, and having a little play through some of these questions as well. You should be able to pause at the start of each question, have a go, and then you can see how I would attempt it, or if you want to fill it in as you go along like we did with the GCSE regular maths one, then you are more than welcome to as well. Okay, so first off, this one's just asking us to differentiate. Remember that you multiply down by the power and then you take one off. So here we would end up with 6x to the power of 5, but that's still over 2, so it's 6 over 2x. And then likewise with the other one, we'd have 4x to the power of 3, taking one off the power, but that's all divided by 4. It wants us to simplify our answer, so we can't really leave it in that form, and you should always want to simplify that anyway. That would be 3x to the power of 5 plus x to the power of 3. An easy 2 marks in the bag. Next, please. This one, a little bit more complicated, I suppose. We know that this is the midpoint. It's the midpoint of those other two. Remember that to find the midpoint, you kind of take the average of the x's and the average of the y's. So we know that if I do minus 12 plus 6, they're the x coordinates, and then divide them by 2, I know that that gives me A, because that's the midpoint. So my negative 12 add 6 is still negative 6, divided by 2 is negative 3, so A is just negative 3, and that's the first answer. The next one's a little bit more complicated because the average is we've got B add negative 2, which is just the same as taking away 2. You halve it and you end up with 4. Going to multiply up by 2 to leave them with B minus 2 equals 8. Going to add the 2 on and B equals 10. Lovely. Okay, here we've got to do our matrices rules. Remember, you multiply the rows by the columns. So I need to do 2 times negative 2, because that's that times that. But then I need to do this 4 needs to multiply by this 2. So I've got 4 times by 2. And that's like the top left. Just going to split it up so now I've got kind of a matrixy thing going on. And then I'm going to do the same with the second column over here. So I'm going to do 2 times 6. And, oh yeah, sorry, I should have an add in there. And where am I? Oh yeah, and 4 times 1. So what I've done is multiplied the top row by the second column to give me that one. And then here I'm doing the bottom row by the first column. Remember that this columns kind of stay in the same order though. So I need to do 3 times negative 2, add negative 1 times regular 2. And then 3 times 6. And negative 1 times 1. Then it's just a matter of sorting all of them out. So this is negative 4, add 8. This is 12, add 4. This is negative 6, add negative 2. This is 18, add negative 1. So all in all, in a nice set of brackets, we've got negative 4 is 4. We've got 12 add 4, 16 there. We've got a negative 6 and a negative 2, so that's negative 8. And we've got 17 there. So again, another quite simple question. I quite like this question as well. So, I just need to move this little display out of the way because I can't quite see. Okay, P is 4x and Q is 7x. P increases by 25%. So 4x increases by 25%. So it gets multiplied by 1.25. Well, a quarter of it is an x, isn't it? So that kind of gives me 5x, I reckon. Q decreases by 40%. So 7x gets multiplied by, and the 7x is decreased by 40%, so that gets multiplied by 0.6, because it keeps 60% if you like. So that would be 7 times 0.6 is going to be 4.2, I think. Is that right? 4.2x. Lovely. And now P is 28 greater than Q. So that means if I want to make these equal to each other, if I want to put an equal sign in, I've got to add 28 on to Q, which is this right-hand side. So I'm going to add my 28 on there. Right, then it's just solving. I'm going to take away 4.2x, which leaves me with 0.8x. That equals 28. So x is 28 over 0.8. If this is a non-calculator paper, then how am I going to do that? Well, I could think about that being 280 over 8, which is the same as 140 over 4, or the same as 70 over 2, or to me and you, 35. Right, next up, we're going to have a little look at this question where it's really going to be about comparing the coefficients. So we know that the coefficient of x squared is equal to the coefficient of x. So I'm going to set myself up a grid like I would do if I had to expand these brackets anyway. So I'm going to have x and minus 3 or negative 3, and then I'm going to put x squared plus 5x just to see where all of these coefficients come from, and then I'll be able to compare them. So plus 5x plus k. Expand that, I get x cubed. I get plus 5x squared. And I get plus kx. Here I get negative 3x squared. Oh, sorry, that's negative. That's negative 15x. I don't know how to get rid of that now. I'll just write negative 15x. And then that's negative 3k. So I need to compare the x squareds, and they're equal to the coefficient of x. So the coefficient of x squared, look, is 5 take 3. Because I've got 5x squared there, I've got negative 3x squared there. So that's the coefficient of x squared, and that is equal to the coefficient of x, which is k take away 15. Then it's a really simple linear equation, isn't it? 2 equals k take 15. So add the 15 and you get k is 17. On this one, a circle has a centre, negative 1, 2, and a radius of 5. Remember that when the centre is AB, the equation of the circle is x minus a all squared plus y minus b all squared, and that equals the radius squared. So straight away, radius squared being 5 means that I'm interested in one of these two because it equals the radius squared. Which one of these is correctly taken away taken away negative 1 and taken away 2? Well, it's this one, isn't it? Because this has kind of added the x and added the y, so that's the wrong way around. So it's definitely that one. Here we've got some circle theorems. Now I do appreciate, I think they're trying to trip you up a little bit here, because you might be fooled into thinking that the x plus 75 is double 2x. Well, it's not. Remember that it's the angle subtended at the centre, so it's actually this angle here that is 2x. Oh, sorry, 4x. Oh, I really don't know how to rub out on this, so I'll just have to do that. So that's 4x, okay? Then we can figure everything out because we know that 5x plus 75 equals 360. And then it becomes a really simple linear equation once again. So we take the 75, get 5x equals 285, I think. And then divide by 5, you get 57. Now some surds. So again, we're just looking at kind of bread and butter marks here. This is nothing that is beyond the GCSE paper, really. This could just be later on in your actual GCSE paper. I'll definitely be doing a grid though to make sure that I don't make any silly mistakes. So I've got 1, I've got positive 2 root 5, might just put the positive on there to make sure I don't make a mistake, and 4, a negative root 5. 4 times, I'm multiplying everything obviously, so I've got 4, add 8 root 5, take root 5, and then this, if you think you're doing 2 times root 5 times negative root 5, I'll just do a little bit of working out over here, that's going to be 2 times by, that would be the negative root of 25, which is just negative 5, so you've got minus 10 there, or negative 10. Put them all together, what have we got? We've got negative 6, because 4 take 10 is negative 6, plus 7 root 5. Should write that on the answer line, sorry. A function of x is 14 take x squared. For all real values of x, solve function of 2x equaling 5. That basically means we're going to put a 2x in here. And you'll see there's an obvious misconception that some people could make. So my function of 2x is going to be 14 take away. It's not 2x squared. It's actually 2x all squared, which is a little bit different because that would give us 14 take 4x squared. And we know that that equals 5. So now it's just a set up and solve, isn't it? I'm going to bring my 4x squared over here. What happened? I'm going to take my 5 so that becomes 9. Then I'm going to divide by 4. Remember BIDMAS. You have to undo it in the reverse order. So 9 over 4. And then you square root him. So x is equal to the square root of 9 over 4. You should recognise that because they're both square numbers, that's going to be 3 over 2. But remember that we could have the positive or the negative of that. Rearrange this to make x the subject. Let's have a little look then. The first thing we could do is multiply everything by xy. That would leave me with 1 equals 4xy minus 3xy over y. So I've just multiplied absolutely everything by xy. Then these y's would cancel out, wouldn't they? So I'd have 1 is equal to 4xy minus 3x. Factorise x out, leaves it with 1 equals x brackets 4y minus 3 close brackets, divide through by that factor. So 1 over 4y minus 3 equals x. X is the subject because it's on its own and it doesn't appear anywhere else. So I'm really happy with that one. Okay, I've got a curve with an equation of 2x squared plus 3x minus 9, and at point P on the curve, the tangent is parallel to this. So straight away, I'm looking at the gradient. The gradient of the tangent is going to be negative 5. And it wants to work out the coordinates of P. Must show our working out. So the gradient can be found by differentiating, looking at the rate of change with y with respect to x. So again, I'm going to times down by the power, that becomes 4x. I'm going to take 1 off the power, so it's just 4x to the 1, which we don't often write to the power of 1. And then that becomes just 3. The constant of 9 disappears when you differentiate. So I know that the gradient has to equal -5, so I can put that equal to -5. So -5 equals 4x plus 3. I'm going to take away the 3, -8 equals 4x. And so I've figured out that the x-coordinate is -2 at this point. But point P on the curve doesn't only have an x-coordinate. I know that the x-coordinate is -2, so I can put it in. Now I have to substitute back into this to get y. So y equals 2 lots of -2 all squared. Add 3 lots of -2, take away 9. So that's going to be 2 times 4 is 8, take away 6, take away 9, that's 8, take away 15, so the y coordinate is -7. A is the point 15, 0. So that's already been on there, and B lies on the y-axis, so B is definitely some sort of y-intercept for sure. Angle ABC equals 90 degrees, and tan theta equals 3/5. So the tan of theta equals 3/5. Tan, remember, is opposite over adjacent. So I know I've got a right angle triangle there that is in the ratio of opposite 5/3. I might have said 3/5 at one point, and that says 5/3. So opposite is 5, adjacent is 3. But look, the adjacent isn't 3. The adjacent is actually 15, if you think about it. So that's been multiplied by 5, which means that this would be multiplied by 5 to give 25. So this length here must be 25. So the coordinates of B, therefore, are 0, 25, which is going to be really, really useful, okay? I can also, I need the equation of the line BC. So I've got its y-intercept. I know that it's going to be something plus 25, because that's the y-intercept. I just need its gradient now. Well, I can figure out the gradient of this line here by thinking about rise over run. The rise over the run, or m, the gradient for this, the rise over run, well, it actually goes down 25 as it goes across 15, or if you like, -5/3. These are perpendicular lines because they meet at a right angle. So m of this must be the negative reciprocal. So this one is going to be 3/5 for that one. So therefore, the equation of BC is y equals mx, 3/5x, plus c, which is 25. And there's the marks. I know I've got most of those by scribbling on the diagram, but they will do those for you. So I've used the tan theta ratio to let me know the proportions of that triangle. That's given me the y-intercept. I've used the fact that gradients are negative reciprocals of each other, and then I've just pieced it together to give me the equation of my straight line. So y equals 3/5x plus 25. Solve simultaneous equations, do not use trial and improvement. Don't worry, I wasn't going to. I'm going to sub y straight away in here. So I'm going to say, right, x times by 3x plus 5 is actually the thing that equals 2. Expand the bracket out, 3x squared plus 5x equals 2. Put it equal to 0 so that I can have a fair crack at solving it. 3x squared plus 5x minus 2 equals 0. And then I'm going to factorise. I'm guessing it's going to be 3x and x. and I have got -2. If I put a 2 there, I don't know why it does that sometimes. If I put a 2 there, a +2, that's going to make me positive 6x. If I put a -1 here, that multiplies to give -2, but it adds to give 6x, take away 1x, so the 5x. So I think my x values are a third and -2. And now just need to think about my y values. You could, either one seems to work quite easily to get the y values. If you think about rearranging this one, y is just 2 over x, isn't it? So 2 divided by a third is actually 2 times 3, so y would be 6. And 2 divided by -2 is -1. So there are my solutions, saved by the bell. Now it's time to just show that you can expand a pair of brackets, I suppose. So you're going to treat this as if it was any binomial, and just go 3 to the power of a half, 3 to the power of 3 over 2, and that's all being multiplied by the same thing. So 3 to the power of a half and 3 to the power of 3 over 2. Just so that I know I'm getting the signs right, I'm just going to put positive on. Well, I know that they're all positive. And then it's just using the laws of indices that you've known since year 8 or year 9-ish. So that's going to be 3 to the power of just a half, add a half, because you add the powers. So that's 3 to the power of 1. This is going to be 3 to the power of, well, that's 3 halves, add another half. So 3 to the power of 4 halves, just 3 to the power of 2. Again, this is going to be 3 to the power of 2, and then this one is going to be 3 to the power of 6 halves, which is 3 to the power of 3. And they're all positive, so you've actually got 3 squared is 9, add another 9, add 27. So as long as we can add up all right, we'll be okay. So 3, add 18, add 27, which is 21. Add 27. Sorry to do this in such a slow way, but your overall answer is 48. Questions like this have started just about sneaking in on the GCSE. So here we've got a graph of 3x minus x squared. So it's a negative parabola, as you can see, because it's got the negative x squared for the values from -1 to 4. And it wants us to draw a suitable linear graph on the grid to work out approximate solutions to this. Now that's really, really interesting. It ultimately means that if I put the equation of the line that I've got, 3x minus x squared, what do I want to put that equal to in order to turn it into this thing here? So, I'm going to take away 3x from this side. I'm going to add x squared from the right-hand side as well to make it equal to 0. So what else do I need on here? Well, if you think about it, I'm going to subtract 3x and I want a -4x. So I think I want to have a negative x here. And if this isn't quite making sense, I'll show you how it works in a minute. And I'm also, I think, going to want a +2, because if I then start rearranging this to make it equal 0, well, I'm going to take 3x and I'm going to add my x squared. So I'm going to take 3x here and add an x squared. That's going to all equal 0, and this would now equal a +x squared, -4x, and a +2. So it now equals what we're after up there. So it's just about thinking what else did I need on the left-hand side in order to, when I put it equal to 0, get what is after, get the equation that it's after equal to 0. So that means I need to plot the graph of y equals -x plus 2. I need to plot this little thing here as a straight line graph. Well, I know the gradient of that is -1. I know that it crosses the y-axis. at +2. Oh no, I'm not very good at doing this. So it's got a -1 gradient. So it goes along 1, and you need to read the scale here, look. It goes along 1 and down 1. So that would be a point as well. Along 1 and down 1. Along 1 and down 1. And then you draw a nice straight line. Now, my straight line on here, unfortunately, is going to be pretty poor. But what we're interested in is where this is going to hit the graph. So I draw my line right across. Just checking that there are 2 answers to this. Yeah. So I'm going to draw my line nice and straight with a ruler and a pencil. And I find that these intersect at these 2 points here and here. And it just wants to know, because we're solving an equation in terms of x, it just wants to know the 2 x values. So I'm interested in this x value here, and I'm interested in this x value just here. Looking on there, it's just past halfway, isn't it, between 0 and 1. So I'm going to say that's 0.6. And what's this one? It's just under 3.5, isn't it? So we could say 3.4 or 3.3, and either one of those would work, and that would be great. Thank you very much. Now, this question is asking us to sketch a curve on the grid below, and what do we know about it? We know it's a cubic curve, so straight away I'm thinking that the shape is going to be something like that, with a maximum and a minimum stationary point. Well, that would be these 2 points here that I've done little dots on, because that's where the graph kind of maxes out and minimums is out, for want of a better phrase. The fact that they're stationary points means that the gradient, or dy by dx, would be equal to 0 at those stationary points. And then it gives me an expression for dy by dx, which I'm going to use in a second as well. The y-coordinate of the minimum point is 2 1/3. The y-coordinate of the maximum point is 13. 0, 4 is a point on the curve, and the tangent at 0, 4 has a negative gradient. So again, if I stitch this to my little diagram like this, and I've got a maximum point and a minimum point, because that's what a positive cubic looks like. And then it's telling me that the tangent at 0, 4 is negative. So the tangent, if I draw like a tangent there, it's going to be going downhill. So I think that means this crosses the y-axis somewhere here, because that's where the gradient would be negative. So straight away, I know that the y-intercept is going to be in that middle bit, and it's just about stitching all of that information to what the graph looks like. I'm going to sketch the curve on the grid below, show the coordinates of the stationary points. Well, if I know that at the stationary points the gradient is equal to 0, it effectively means I know that x squared plus 2x minus 3 has to equal 0. And I can factorise that. It's, what is it, x plus 3 and x minus 1. Okay, and that means that I've got x is equal to -3, and x is equal to 0. Well, again, if I look back at this shape of my curve, I know that this one is going to be the -3 one. Sorry, I'm up at the top again. I know that you can't actually see my pointer when I'm moving it around. And that, oh, sorry, I don't know why I put 0 there. That's equal to 1, isn't it? And that this point, when x is 1, will be this minimum point. So the -3 is the maximum, and the x equals 1 is the minimum. So if I draw my graph now with all the information that I know it kind of goes up, then it comes back down before bottoming out and then carrying on. And the reason I know it comes back down is because it's got a negative gradient at the point 0, 4. So that's that one. I know that here, let's call this the maximum point here. That's got a coordinate of -3, and if I look back at the information it gave me about y's, the y coordinate of the maximum is 13. And then I also know that here, on the minimum point, x is equal to 1, and the y coordinate of the minimum point is 2 1/3. So that's how my graph must look. Obviously, if it had given me a negative y coordinate here, where I've just pointed that little arrow, then I would have known that it stretches further down below the x-axis, but because it doesn't, I know that it must be there, and I think I've got all of the, how many marks we're looking at there? I think it's a 4 marker, so all 4 marks done. Now there's a lovely bit of factor theorem. It says use the factor theorem to show that x minus 2 is a factor of this expression here. Well, if x minus 2 is a factor, that means x must be equal to 0. Sorry, x must be equal to 2. Because remember, you kind of put that bracket equal to 0. If x minus 2 was equal to 0, then x would equal 2. So I'm going to substitute 2 into the expression. And if it's a factor, then I should get 0 out. So I'm going to go, right, I've got 2 cubed plus 8 lots of 2 squared plus 5 lots of 2 minus 50. So I guess I'm effectively looking at the first 3 bits, the first 3 terms, summing up to give 50, and then taking 50 off and getting 0. So let's have a look. I get 2 cubed, which is 8. 2 squared is 4. Times by 8 is 32. So I'm on to 40 there. And then I'm going to add 5 times 2, which is 10. And then I'm going to take 50 off. Now, you can obviously work through this and say, look, I've got 40, add 10, take 50, but it's only 1 mark. So at that point, if you're sure that it's 0, you can just whack it in as 0. Now it says hence fully factorise. So when it says hence, you've probably already got something useful somewhere to use. So make sure you use it. I know that I've got x minus 2 as a factor is something useful. So here I can either do the long division, the algebraic division, or I can compare coefficients. So what that means is, if you think about what your expansion would look like, you've got x minus 2 is multiplied by something, so you know it's going to have to be x squared, because that would give you x cubed. You know it's then going to have to be a number of x's. I don't know how many, so you could put a constant number of x's. And then actually, I'm going to guess that this one's going to be plus 25 straight away, because negative 2 times plus 25 gives me the negative 50 that I'm after. I knew that this was x squared up here because I knew I was trying to make x cubed. So now I've made that. It becomes a little bit simpler then, because you know you get negative 2x squared here. You get positive kx squared there. You get 25x here, and you get minus 2kx here. And you can just compare, you can use either one of either the coefficient of x squared or the coefficient of x to figure out what k is now. And in fact, you can use one and then use the other as a kind of a double checking technique. I will show you algebraic division as well, just in case you'd rather that. So I know that minus 2 add k must give me 8x squared. So I know that that must give me positive 8, which would mean k would have to be 10, I think. Is that right? Yeah. So k would have to be 10. To double check that, you can look at the coefficient of x, and we know that 25 minus 2k has to give me the coefficient of x, which is 5. So negative 2k would have to give me negative 20. So k would be 10 again. And either way, that means I've got x minus 2, all multiplied by x squared plus 10x plus 25. Well, it wants this factorised fully, so that would actually be x minus 2 multiplied by, can I factorise this? Yes, I can. It's going to be x plus 5 as a repeated root. So x plus 5 and x plus 5. And if you wanted to put x plus 5 squared, then you could. So that's the final answer. You can do x minus 2. And if I want to write it efficiently, x plus 5 all squared. Now, the algebraic division that we could have done, I will just do quickly here to get us to this step. Here you would still need to factorise. So you could be looking at x minus 2. By the way, this is an extra. If you liked the comparing coefficients method, then just use that. But if you want a little reminder of some algebraic division, here it is. So we're doing x minus 2 all into x cubed plus 8x squared plus 5x minus 50. I know I need to times by x squared to get me my x cubed, but then I look at what the negative 2 times x squared would be. Well, that would be negative 2x squared. Then I subtract down, and that gives me 10x squared. The way of getting 10x squared, 10x squared divided by x is positive 10x, and that gives me 10x squared. But drag the 5x down for comparison. It also gives me minus 20x, which overall, 5x take away 20x gives me minus... have I made a little bit of a mistake here? Oh, I'm taking away negative 20, so that actually becomes positive 25x. Drag the negative 50 down, and it's still going to work out nicely because 25x divided by x is just plus 25, which would give you the 25x, but it would also give you negative 50, and so you haven't got a remainder. Now that's a little bit of a bonus. I do appreciate that's a little bit trickier, but you definitely use that method at A level, so it's worth having a look at. And there, look, we're back at having this x squared plus 10x plus 25, which you still need to factorise for your final answer. That's where you're getting your 3 marks. But there's a lot of information on here, and I think it's quite a tough question actually to answer. So you really want to pay attention to quite a lot of this. So D, E, F are points on a circle. That means there's a cyclic quadrilateral going on. RST is a tangent. So that means that if there was a radius to it, that would be meeting at 90 degrees, but I'm not sure if we need that or not yet. The straight line, EDT, is parallel to FS. Well, that's handy because they've labelled that up on the diagram for me as well. And DS to DT are equal. And again, they've labelled that up for me in the standard way. Prove that FD is parallel to RST. So we want to prove that FD, so I'll just draw these on, that FD is parallel to RST. So I need to prove that these two are parallel. I think there's a really clever way of doing this actually, having looked at this question for a minute. You can use the angle DTS as x to help you, and they've put that in already up here. Now if that's x, this one must be x because it's an isosceles triangle, and I would be tempted to write your reasoning as you go through on these. So that's why that's x. Isosceles triangle. We kind of know we've hit 1 mark there. So by that, then, this angle up here must be 180 take away 2x, because angles in a triangle have to add up to 180. If that's 180 take away 2x, because of these lines being parallel, these ones here being parallel, that means that this is also 180 take 2x, and that's because they are alternate angles in parallel lines, because that one and that one up there are alternate angles, so they're equal. If you think about it, if that's 180 take 2x and this one here is x, then this must also be x. Now next comes the clever bit, because I think this one here, the fact that DST is x means that this one is again x because it's alternate segment to DST. Well, now that we've shown that these two are alternate angles, and they're alternate created by FD and RST. So they're created by a transversal between them because we've shown that this is X and this is X. Therefore, FD is parallel to RST. And I think that's the messiest question on this paper, actually, because there's just lots of bits and bobs to kind of call out, and you're basically just saying everything's X. But if you look back through all the reasons, you're kind of working methodically through to show that you've got some alternate angles, which must mean that those two lines are parallel. Right, next up, it's a little bit of completing the square. It's the hardest version of completing the square, admittedly, but we will be all right with it. So, first off, if you look at it, it's asking us to do 2x squared minus 16x plus 13 in this form. Now, they've taken a factor of a out, which I think kind of prompts you to take in a factor out here. The reason that we don't want to complete the square at this point is, and I'll just do it over here, look, if I try and complete the square here, I've got to end up with root 2x minus 8 over root 2 all squared or something daft like that. It's actually really quite hard to consider. So I don't really want that. We want usually to have like x minus a constant or plus a constant all squared. So the way that we can do that is by pulling this factor of 2 out. So we could say, hey, look, we've got two lots of x squared minus 8x. And then you don't even have to pull the factor of 2 out of the 13. You can kind of leave it separate, as we often do when we're completing the square anyway, because then we can complete the square for the inner bit. We've got two lots of, that would be x minus 4 all squared. But remember, you get that waste product of 16 that you don't actually want. So it's all that, but then you don't want the 16 that that produces. You want the 8x that produces, but you don't want just the regular 16. So you've got two lots of that, and you've still got your plus 13 here. So next up on that, you can expand the first bracket. So you can say you've got two lots of x minus 4 all squared, but that would be minus 32 because you've done 2 times the 16. You've got the add the 13. So then it's actually two brackets, x minus 4 all squared minus whatever that is. What's negative 13? Sorry, negative 32, add 13, 19. And that's it. So your answer would be two lots of x minus 4 all squared, take 19. Now, I hope you've taken some breaks during this because you've now listened to me talk for 43 solid minutes. Okay, this is I think it's the last question, which is cool. So we've got a right angle, a non-right angle triangle with kind of matched up sides and angles here. So I've got angles opposite sides. It automatically makes me think of sine rule. They've put the values on there and I'm trying to figure out x. Remember that I think it's best to have the unknowns on top with whatever iteration of sine rule you're using or whatever you're trying to figure out. I think get the thing you're trying to figure out on top because it means that you multiply up to isolate that thing. So I've got x is over sine 45 and that equals 6 root 2 because I've got my sides on top over my angles sine 60. Now I'm going to use the finger trick to figure out my exact same values. If you hold your left hand out in front of you and you call your little finger 0 and you go 0, 30, 0, 30, 45, 60 and 90 all the way up to your thumb, then you put that finger down and sine is always the bottom, how many fingers you've got underneath. Cos is always how many fingers you've got on top. You square root that, you divide it by 2. I've just been doing it this afternoon with my my year 11s, so that's why I've got it in my head. So I think that x then is divided by sine 45. So 0 is my little finger, then it goes 30, then it goes 45, so I'm putting that finger down. I've got 2 fingers on the bottom, so I think that means sine 45 is root 2 over 2. Next, I've got 6 root 2, I haven't done anything with that yet, and sine 60, so 0, 30, 45, 60, putting my index finger down. That means I've got 3 on the bottom, and sine is on the bottom, so it's root 3. Always over 2, interestingly enough. Great. Now I've just got a bit of it's not the easiest equation in the world to solve, but I think I'll figure it out. I'm going to multiply up by that and multiply up by that at the same time, so that I've got x root 3 over 2 is equal to 6 root 2 times by root 2 over 2. So I've multiplied up by the 2 denominators. That leaves me with x root 3 over 2 is equal to, well, that would just be 6 times 2, but then divided by 2. So I think that just comes to be 6, to be honest. I'll times up by 2 at that point. That's x root 3 equals 12. And then I've got to divide by root 3, so x is 12 over root 3. You should see a problem with leaving that as the answer, really. One, it doesn't look anything like it wants the answer, but also we've got to rationalise the denominator. So I'm going to times top and bottom by root 3. And that leaves me with 12 root 3 over 3. And 12 divides by 3 nicely, so I'm going to write my answer back underneath the question. I think that gives me 4 root 3. Well done for listening to that. Obviously, you can kind of scan back and you'll know that, I don't know, each question took roughly 3 or 4 minutes to have a look at. And if there's anything you're unsure of, then just come and see me. Thank you very much for your determination in listening and for putting up with my voice. Okay.